Welcome to online classes of SHIVAJI Group of Institution. Student, myself Jitendra Tripathi. Student, in previous class we learned about the Charles law. Today we are going to start some other numerical problem based on Charles law. So, one question is, a dry gas occupies a volume of a dry gas occupies a volume of 1054 decimeter cube. Okay, at a temperature of minus 73 degrees centigrade. Minus 73 degree centigrade. Okay, at what temperature its volume is 4216 decimeter cube when the pressure remains constant. Okay. First of all, pressure is constant. Initial volume 1054 decimeter cube and initial temperature minus 73 degree centigrade. This degree centigrade temperature must be converted to Kelvin by adding 273. So this comes out to be 200 Kelvin. Now volume becomes 4216 decimeter cube and temperature degree centigrade temperature. So by applying Charles law, V1 upon T1 is equal to V2 upon T2. Must we calculate T2 first? So V2 into T1 upon V1. Substitute all the values. V2 is 4216, T1 is 200 and V1 is 1054 decimeter cube. On solving we get 800 Kelvin. This is the absolute temperature, but we have to calculate degree centigrade temperature. So T2 equal to T2 minus 273. 800 minus 273. This comes out to be how much? 527 degree centigrade. So this is the answer. Okay. Now, next topic for this chapter concept of gas equation. What is gas equation? A mathematical equation used in calculating the change in volume when the initial temperature and pressure of an enclosed gas simultaneously change is called gas equation. A mathematical equation used in calculating the change in volume. Change in volume when the initial temperature and pressure of gas simultaneously changes is called gas equation. It means if we placed a gas in a container, then initial volume changes by changing the temperature and pressure of gas simultaneously. So equation comes out to be known as gas equation. This equation derived by combining equation can be derived by combining Boyle and Charles law. Okay, so first of all, by applying Boyle's law, what is that? V inversely proportional to P. Okay, say equation first, and by applying Charles law, V directly proportional to absolute temperature T, equation second. From equation first and second, left hand side for both equation are same, so V proportional sign to T upon P. Okay. By removing the proportionality sign, V equal to K times T upon P, or we can write PV equal to K into T. Okay. So K equal to PV upon T. For two gases, P1 V1 upon P1 equal to P2 V2 upon P2. This is formula for gas equation, and using for the some numerical. So check it and start with the numerical. Okay. Numerical: 1.5 decimeter cube of dry hydrogen gas. 1.57 decimeter cube of dry hydrogen gas is at pressure of 750 mm of Sg. Is at pressure of 750 mm of Hg when the temperature is 37.5 degrees centigrade. When temperature is 37.5 degrees centigrade. Find the volume of gas at STP. Find the volume of gas at STP. Do you know the meaning of STP? The standard temperature pressure. So initial solution. See here, initial volume is 1.5 centimeter decimeter cube and pressure is 750 mm of Hg, and temperature is 37.5 degree centigrade. You must be converted to Kelvin by adding 273. This comes out to be 310.5 Kelvin. Now at STP, you must be calculate volume V2, but pressure P2 is at STP is standard, that is 760 mm of Sg fixed, and temperature T2 standard temperature is the 273 Kelvin. Okay. Now applying the gas equation. Gas equation is the P1 V1 upon T1 equal to P2 V2 upon T2. Now you may go for the V2. Question mark as that V2. So P1 V1 T2 upon T2 T1. Okay. Now substitute the value. P1 is 750. Initial volume is the 1.57 decimeter cube and temperature T2 is the 273, T2 is the 760, and T1 initial temperature is 310.5. Substitute all the value and solve it. So answer comes out to be, by solving, 1.36 decimeter cube. This is your answer. Okay student, this is all about today, and after completion of this numerical, the chapter is completed. So in this chapter you may learn about Boyle's law, Charles' law, and gas equation, and based on numerical also. So you must be revise all the other numerical on this topic, and if you are facing any problem, you can discuss with me on my personal WhatsApp number. So okay, for best of attending the class. Thank you.